Hello everyone. This is my program. It's a small program that turns graphs into equations. Over here is where I've defined my libraries. We have the tkinter library, and it's mostly used for the graphical interface. And I also have some libraries like NumPy, the time library. Down here, however, is where we actually have the program. So the program is about 100 lines of code, and it's written in Python. One thing about that is that it's probably not the best idea to write this in Python, since I am trying to turn this into a website. So maybe you would go into the website and you would tinker with variables, see how variables change shapes of the objects that you drew, so on and so forth. That type of application is really most suitable for JavaScript, for example, not so much Python. So I may be changing programming languages soon, but for the meantime, let's just run the program and see what we have. So as soon as you run the program, it gives you this window. And in this window, you can draw lines, for example. Let me draw a few lines. Yeah. And a simple, nice parabola. So yeah, two lines and a parabola. And yeah, just as we expected, it gave us the equation for two lines and a parabola. One thing to note here is that this is the equation for the line, so it's in the form ax plus b. So this is the slope of the line, and this is the point at the origin. And this term, its main function is to actually crop down the line. So for example, if you've got a line, well, it's defined for all points uh, R. So it's defined for all points. But if you want to crop it down, you need to do some math. And that's what this square root is doing. It's cropping it down. This polynomial is in the form ax squared plus bx plus c. And yeah, it corresponds more or less to the parabola that we drew here. One thing that I would like to mention is, for example, if we pull this up, so how could you superpose two functions together? So, for example, if we say we have function f of x, and this is the function in red, f of x, and g of x in blue, we can actually superpose the two functions if we multiply them together. Since, if you've got two numbers, a times b, that are equal to 0, then either a is equal to 0 or b is equal to 0. And so this is how we get to, for example, have two lines that are above each other. Normally, a function, you wouldn't be allowed to do this. You can't have a shape on top of another shape. But if we use this trick, we can actually, rather, this trick, we multiply them together, then it is no longer an equation. Sorry, no longer a function. It's an equation. So yeah, that's how we can superpose two functions together. One last thing that I would like to mention is the polynomial interpolation. So the way I uh, came up with the coefficients for the parabola is through the Lagrangian polynomial. So if we draw ourselves a small parabola like this, what I'm actually doing is having Python take three samples that are equally spaced out from each other. And it takes these 3 points and it feeds them into the Lagrangian polynomial. And what the Lagrangian polynomial does is, for our case, it basically takes these 3 points and gives us the actual uh, parabola. And the formula for it is pretty complicated, but it's not that difficult to prove. So yeah, that's my program. Currently, these are the only two shapes that are acceptable, lines and second degree polynomials. But in the future, we may, not maybe, but I will definitely be expanding this to include circles and cosine trigonometric functions, logarithmic exponential functions, so on and so forth. There is much potential for this program to actually grow and become a motivational, educational tool. Sorry. So yeah, that's my program, and thanks for watching.